Hello, my name is Eric Chappell, Community Evangelist for InfraWorks 360, and I'd like to talk to you today about the dynamic duo, InfraWorks 360 and Civil 3D. There's no denying that Civil 3D is a great tool that you probably rely on every day to do your engineering and design related tasks. What you may not know is that when you put Civil 3D alongside of InfraWorks 360, this team just becomes unbeatable. There are simply things that one product does better than the other and vice versa. So why not use the best tool for the job? Let's take a look at some of the tasks that you may currently be doing with Civil 3D, such as establishing existing conditions, preliminary road and storm design, stream crossing analysis and design, as well as detailed design and documentation for these items and others. And let's take a look at how well they can be done with Civil 3D and InfraWorks 360 together. So let's talk about the task of establishing existing conditions, and specifically the goal of developing a backdrop for preliminary design. So the point we're talking about here is before you have a survey done. Maybe it's early in the project or at a time when you're actually chasing the work, and it's just not feasible to have a survey done. And it doesn't have to just be survey. It could be having the site flown or having LiDAR data collected. Whatever means is being used to get accurate existing ground information, it's just not time to do that yet. And you need to develop this backdrop with freely available data. With all this in mind, how long would it take you or your staff to complete this task? And what kinds of skills would it require? Well, based on what we understand, this is typically done with various online sources of data or just various sources of data in general, wherever you can get them. And to do what needs to be done with this data, you're going to require the use of some Civil 3D tools, namely for building a surface out of this data. You're going to need some map tools for consuming GIS data, and possibly even some additional tools, third-party tools for doing conversions and that sort of thing. So let's take a look at a comparison between establishing existing conditions using Civil 3D versus InfraWorks 360. And we've got a video on the left of Civil 3D and on the right is InfraWorks 360, and we're giving Civil 3D a huge head start. You can see on the left we've got about a 6-step process. We've broken it down into 6 steps for Civil 3D, and on the right the InfraWorks 360 is only about 3 steps. Now right now we're in the acquiring data step, and we don't even include the time it takes to just locate the data. That can take a lot of research, or if not research, a lot of know-how as far as where to find the kinds of data that you need to perform this kind of task. Depending on how lucky you are or where the project's located and what you have access to, you could easily spend a few hours just locating the data that you need. We didn't even include that in this example. We've been through acquiring the data and translating the format, and now we're looking at configuring the Civil 3D environment. Compiling all this data is very sensitive to coordinate systems. If you don't have a good understanding and a good mastery of coordinate systems, you're not going to have success with putting all this data together. The 4th step here is to create a surface from the GIS data. So we've given Civil 3D nearly a 5-minute head start, and now we're actually up and running with InfraWorks 360 on the right. On the left with Civil 3D, we're capturing imagery from the Bing Maps imagery that's embedded in the product. But we've also got access to imagery through our InfraWorks 360 means as well. Next, we're importing some vector data, so maybe some shapefile data that we've acquired, and we're bringing that into Civil 3D to represent things like roads. So you can see how things worked out. What took 7 minutes in Civil 3D only took a little less than 2.5 minutes in InfraWorks 360. And again, we didn't include the research involved in actually finding the data. We're going to give the Civil 3D user the benefit of the doubt that they already knew where the data was. And I'm going to bet, though, that if you've done this before, you know how much time that can take. So even with that, InfraWorks 360 was still able to do what needed to be done in about 1/3 of the time. And we also have a very different end product. In the Civil 3D drawing, we've got an aerial image with some contours and lines. And provided we do have a surface in Civil 3D, so we have some 3D data available, but it's really not even a comparison to what we end up with in InfraWorks 360. A 3D model with terrain, with draped aerial imagery, 3D roads that have curbs and sidewalks and grass strips as you see in the image in front of you, 3D water features, buildings. There's lots of different data that Model Builder has access to, and you can see the 3 simple steps for the InfraWorks 360 example. Open Model Builder, find the area of interest, and just create the model. So it's a very simple process, and it doesn't require a whole lot of training to learn how to do it. But that's not the end of the story. Even though InfraWorks 360 obviously outperforms Civil 3D in that part of the scenario, there's another part that Civil 3D steps up and becomes the hero for, and that's when we're talking about when accurate ground data is obtained. So let's say you've won the project and now it's time to go out and get that survey data or that LiDAR data. And when you get that data back from the field, you're going to need to process it, you're going to need to build an accurate surface, and then do detailed documentation of the existing conditions of that site. That's the part you need Civil 3D for. So then if you want to, InfraWorks can still be part of the story. You can take that accurate surface created in Civil 3D and you can bring that into your InfraWorks model and make that part of the model just as accurate as your Civil 3D drawing. So again, the products working together are much bigger and better than they are working by themselves. So let's do just a side-by-side comparison of what we've seen. When we're talking about establishing existing conditions, with Civil 3D, we're looking at hours spent locating data, whereas with InfraWorks, all the data is at our fingertips. There's no time spent researching and locating the data. With Civil 3D, you need some really expert skills to be able to master all those different parts of the software that are required to bring that data together, to build a surface out of it, to have all the sources of data overlay each other, to have that mastery of coordinate systems. Lots and lots of skills required. With InfraWorks 360, it's a really simple process. It's something that you can learn to do in about 5 minutes. With Civil 3D, it's a multi-step, a lot of times a messy process because of all these different data sources that are out there in different coordinate systems, written with different metadata. It just ends up being a messy process. Whereas with InfraWorks 360, it's really a single step, create, model. InfraWorks 360 does all the work for you, going out and gathering the data, putting it all together, keeping it all in the right place geographically. And then finally, your end result with Civil 3D alone is just an aerial image with contours and lines. But with InfraWorks 360, you get this robust model with the terrain and draped imagery and 3D features. Now, that's all before you get the survey. Then once the survey data is acquired, then the spotlight switches to Civil 3D. And now Civil 3D is the tool that I can use to generate detailed existing conditions and even create a document that represents the existing conditions of the site that a surveyor could stamp. Now, that's not to say that InfraWorks 360 has to step off the stage. It can still consume that data. In fact, you can take your InfraWorks 360 model and make it even better by incorporating the accurate Civil 3D terrain data into it. And then finally, looking just at the overall results. With Civil 3D alone, you get a pretty good product. You get a detailed existing conditions drawing, something I'm sure you're very familiar with. But when you're working with both products together, you get that plus an in-context 3D model of not just the area that you've surveyed, but up to 200 square kilometers of surrounding landscape, possibly cityscape, roads, water features, maybe some rail. That context has a huge role in telling the story of your project, not just where it is in the immediate area, but how it's going to impact the areas that surround it. Let's talk now about the topic of preliminary road design, with the goal being to develop a quick road design, but with design principles that actually work. meaning it should use engineering-based horizontal and vertical design. Horizontal curves, perhaps spirals, vertical curves that are parabolic or whatever standards call for in your area. And it should be reasonable as far as cut and fill. So we can't just make a straight road across a ravine and have a massive amount of fill and expect that to be workable. So how long would it take you or your staff to complete this task, and what kinds of skills would this require? Let's take a look at a comparison between Civil 3D on the left and InfraWorks 360 on the right as far as it applies to preliminary road design. So as you can see on the left, we've broken down the Civil 3D procedure into a 10-step process. And it starts out with sketching out the path of the road centerline and then turning that into an alignment. Then we create an existing ground profile by sampling the surface, and then next we create a design profile. So currently our Civil 3D user is in the process of doing the design profile. After that, for this particular example, we're going to do a secondary road, a short road that runs north and south that creates a T intersection. And you'll see we'll do the same thing in InfraWorks as well. Now once we've got our alignments and profiles in place, we have to create an assembly. We have to define the cross-sectional area of the road. Now I want to point out that all this stuff we're doing in Civil 3D isn't necessarily bad. It's just extremely detailed. It's a design environment where we have control over every tiny little aspect. And although it's very, very functional and very appropriate for detailed design, it may not necessarily be the best choice for that quick, rough preliminary road design that we do early in the project. So you can see now we've created a corridor surface so we can get some contours on the road. We're designing the intersection, and then finally we have to spend some time cleaning up that surface. You can see we've got contours outside of the road area. So if you've done this before, or if you've seen your staff do this before, this should all look quite familiar. So our Civil 3D user is still in the process of designing this intersection, and I just want to point out that intersection design in the InfraWorks 360 example is literally effortless. You don't have to do anything. Now we've given Civil 3D about a 16-minute head start so far, and we're about ready to just kick off InfraWorks here any second as we're finishing up the Civil 3D model. Again, still getting that surface cleaned up, making some adjustments. And now we finally launched the InfraWorks process, and by the time I even mention it, it's already taken place. So what took us 19 minutes and 38 seconds in Civil 3D only took us 40 seconds in InfraWorks 360. The end result in Civil 3D, we've got kind of a wireframe model with some contours, so it's definitely a design. It definitely can be utilized for more detailed design and documentation, but to visualize this road would take a lot more work. On the right side, we've got the InfraWorks model where we not only have a very realistic looking road, but we also have the context of the surrounding area that InfraWorks is so good at providing. Now I realize that the InfraWorks demonstration went very quickly, so let's see that again in a little bit slower motion. The process of doing it in InfraWorks 360 is basically launch the tool, select a style, and pick points to draw the road. And InfraWorks 360 is so good and so smart, it automatically cleans up the intersections for us. It automatically picks elevation points based on the terrain and tries to come up with a reasonable solution for the profile of the road, and it does it in an amount of time that's just almost like magic. But that's not the end of the story. And again, InfraWorks is a good product by itself, Civil 3D is a good product by itself, but when you put them together, they can really do amazing things. So after we've done that really fast 40-second preliminary road design in InfraWorks 360, and maybe we've tweaked it a little bit and gotten it just the way we like it, we can now move that right into Civil 3D. That InfraWorks 360 model can literally be opened in Civil 3D. And then we can use Civil 3D for what it's designed for, and that's for performing the detailed design and documentation of the road. For example, the cross sections that you see in the image here. And the story doesn't even have to end there. Once we've done detailed design and documentation in Civil 3D, we can take that information and open it in InfraWorks and show that detailed design in the context of all that surrounding data, the terrain, the buildings, the roads, the water features. And we're able to tell the story of that design so much more clearly and with so much more detail because we've got it in that context. So let's look at a quick comparison of doing preliminary road design with Civil 3D alone, which may be what you're doing now, versus Civil 3D and InfraWorks 360 together. With Civil 3D, we've got a 10-step, 20-minute process. With InfraWorks 360, we've got a 3-step, 40-second process. With Civil 3D, we need an expert level skill set and a lot of experience to be able to build a road that meets minimum engineering requirements. Whereas with InfraWorks 360, we can do this very quickly with minimal training required. Civil 3D alone really applies more detail than what you need for a preliminary road design, whereas InfraWorks 360 is designed to have just the right amount of detail for that phase of the project. Civil 3D, no assumptions made. As a designer, I have 100% control over what the output is, and that's where I want to be from a detailed design standpoint. But in preliminary design, I'd like my software to make a lot of assumptions, so I get a quick design, but it's fairly smart. It's not something silly that could never be built. Now that's the preliminary design stage. When we get to the detailed design stage, the spotlight is now focused on Civil 3D. That's the tool that has all of the power and that 100% designer input that lets you get the exact detailed design that you need out of Civil 3D, not to mention the documentation aspect, generating those construction documents. In InfraWorks 360, we can still utilize that product in the detailed design stage as a visualization tool for allowing us to see, or allowing an audience to see, that detailed design in the context of all that surrounding data. The final result, with Civil 3D alone, you're going to get a pretty good product, a detailed design model, and construction documentation. With Civil 3D and InfraWorks 360, you get all that plus an in-context 3D model. So let's talk about the task of preliminary storm design. The goal here being to develop a quick storm system design comprised of inlets, manholes, and pipes for viewing and cost estimation. Now, this should utilize engineering concepts of slope and elevation, and it should include sizes for estimation purposes. So, in other words, it should be more than just a pretty picture. So how long would it take you or your staff to complete this task? And what kinds of skills would this require? Let's take a look at a comparison between doing preliminary storm design with Civil 3D and doing it with InfraWorks 360. You can see on the left we've broken down the Civil 3D process to 7 steps. We've found the low points, we've laid out the spacing of the inlets, and now we've gone through the process of the first wave of creating inlets and pipes. Then we spend some time repositioning and adjusting the orientation, rotation, and location of the inlets to be at just the right spot for the curbing. Now, I want to point out that all of this control of detail is not a bad thing. It's actually a great thing when you're in the detailed design stages of a project. But it's a little more than you really need for a preliminary storm design. Having to worry about the exact position of every inlet and the invert at either end of every pipe. Wouldn't it be great if you could have a solution that would make a bunch of assumptions and give you a great starting design without a lot of time or effort up front? Civil 3D, again, is a great tool for the detailed aspects of designing the storm, but it really has too much control, too much attention to detail for a preliminary storm design. So you can see now our Civil 3D user is creating inlets on the other side of the road and adjusting all the labeling. So on the right side we have InfraWorks 360, which is going to go through a 3-step process, which is really just a matter of launching commands and sitting back and waiting. We've got add pavement drainage, we've got quantities, and we've got size pavement drainage. And that went so quickly it ran out of time before I even finished talking about it. The end result for the Civil 3D only solution is a storm system with educated guesses for sizes. If I were to slow down the video to the part where our Civil 3D designer was working on the sizes, he did actually go through and pick some sizes that You can get pretty close just based on experience. But still, they're just educated guesses. We didn't run our scenario on the left with any hydrology and hydraulic design at all, which we certainly could have, but that would have added even more time to already a 23-minute process. So I realized the InfraWorks 360 example went very quickly, so let's take another look at it at normal speed and talk about some of the power behind this product. All I did here was I selected a road, right-clicked, and picked Add Pavement Drainage. InfraWorks 360 applies a lot of assumptions and some rules and lays out all the inlets I need based on low point and minimum spacing. I also launched the quantities command, which brings up a handy panel on the screen. It's actually called an asset card that shows me all of the quantities of inlets and manholes and pipes and even outfalls that I need for this design. After that, I'm going to launch another command just simply called Size Pavement Drainage. Again, InfraWorks 360 is going to make some assumptions about rainfall amounts and estimated flows to each of these inlets, and using that information it can actually size all the pipes, automatically adjusts all of my quantities for me. So with InfraWorks 360, my result is a storm system with sized pipes and outfalls based on engineering calculations, real data, and in this amazingly striking visual environment with all of the surrounding context. Of course, the story doesn't end there. It's not just about InfraWorks 360, it's about InfraWorks 360 and Civil 3D working together. So after creating and adjusting that initial preliminary storm design in InfraWorks 360, I can then take that and literally open it in Civil 3D and continue working on it in a detailed design and documentation mode. Then, once that's complete, I can move that back into InfraWorks 360 if I want and view that detailed design in all of that context that InfraWorks 360 is so good at providing. So let's look at a comparison of Civil 3D alone versus Civil 3D and InfraWorks together. With Civil 3D alone, preliminary storm design is a meticulous, detailed process, whereas with InfraWorks 360, it's a three-step process that takes just over 1 minute in this example. Civil 3D requires a lot of skills. It takes a fair amount of training to learn how to design a storm system in Civil 3D. Whereas with InfraWorks 360, it's a simple process. It doesn't take a lot of training. You're letting the engineering built into the product do a lot of the thinking, figuring, and calculating for you. Civil 3D alone, it's really more detail than you need for a preliminary storm design. Whereas InfraWorks 360 is designed to have just the right amount of detail for that stage of the project. Civil 3D alone, no assumptions made. You need 100% designer input to position every single inlet, the rotation, the depth, the top elevation. Some of those things are automated in Civil 3D, but they are all able to be controlled by the end user. Whereas with InfraWorks 360, they can still be controlled, but assumptions set the defaults. And what you'll find is that the initial result that InfraWorks 360 gives you is pretty good. It usually requires only a minimal amount of adjustment for it to be something that you're ready to show to a customer or someone else you may be working with. Now that's the preliminary design. The story changes completely when you get to detailed design because that's where Civil 3D shines. Civil 3D is a product that's designed to perform detailed design and documentation. Now InfraWorks 360 can still play a role in the visualization of that detailed design. So once you complete your detailed design, or really at any stage in the detailed design in Civil 3D, you can open that information in InfraWorks 360 and view it in the context of whatever other data you have in that model. So then finally, when we look at the results that are output, with Civil 3D alone, we get a detailed design model and construction documentation. That's a lot for our money. But when you put the two products together, you get all of that plus an in-context 3D model. Let's take a look now at stream crossing analysis and design. The goal here is that we're early in the project and we want to calculate the flow and design a culvert for a stream crossing. Now we want something that's more than just a pretty picture. We want to use viable hydrology methods and calculations to determine the flow, and then use engineering concepts of slope and elevation to actually position the culvert in the model. With all this in mind, how long would it take you or your staff to complete this task, and what kinds of skills would it require? Now let's look at a comparison of completing this task with Civil 3D on the left versus InfraWorks 360 on the right. We're going to give Civil 3D a big head start, and InfraWorks 360 is just going to sit and wait until it gets almost done with its process. We've broken down the Civil 3D process into 6 steps. First, identifying the culvert location, using the catchment tool to create a catchment area in Civil 3D, and that gives us some values which we can transfer over into HydroFlow to calculate the flow that's required into this culvert. Then to design the culvert, we need to go back into the drawing and really just roughly position it in the drawing. You'll see the designer draws a simple line that shows where the culvert's going to start and going to end based on the stream channel that's currently in the model. And from that we can determine the elevation at either end and the length of the culvert, all values we need to size the culvert. And then once we've determined the size of the culvert using HydroFlow, we can use that information and the pipe tools in Civil 3D to actually model that pipe and end walls in the drawing. So the same tools you would use to create inlets and manholes and those sorts of things, you would use to create the culvert, the pipe crossing under the road, and the end walls on either end of it. The end result you get here is a detailed culvert design. It's got all the labels, and it's something you could, with minimal effort, move forward into a finished design that could be placed in a construction document. So we've kicked off the InfraWorks 360 side of the procedure, and you can see that this is broken down into 4 steps. And before I can really get into describing what the steps can do at the speed that the current video is playing, it's really over before I even get a chance to do that. So I realized the InfraWorks 360 part of this went very quickly, so let's watch it a little more slowly and talk about what's going on. We start with the Create Watersheds command, which actually uses the power of the cloud to calculate the watersheds that contribute either to a point or to a road. In this case, we've selected the road running down through the center of our project. And InfraWorks 360 will crunch some numbers, analyzing the shape of the terrain, and determine not only where the watersheds are located that contribute flow to that road, but also where the streams are where the concentrated flow passes beneath the road. Now once we've got those streams, we can launch a single command called Add Culverts, and InfraWorks 360 will find where those streams cross under the road and create culverts there. Not only just create them, but also position them exactly where the stream intersects the embankments of the road, and it'll even skew the end walls so that they match the alignment of the stream. Next, we click on the watershed contributing to that culvert, and we choose a method for calculating flow. In this case, we're using the regression method and choosing the right settings for the part of the country that we're in. And then once we've got that flow established, we simply click the culvert and it will automatically resize it to be able to handle the flow that's been calculated. The result that we get is a detailed 3D culvert design, not to mention a 3-dimensional analysis. If you take a look at the graphic on the screen, we've got the blue bar that represents flow in the culvert. We can actually interact with that. We can place our cursor on it, move it up and down, and see the values for depth and station along that culvert. And then we've got additional information about the downstream tailwater condition, upstream headwater condition, even the flow control of the culvert. So we don't just get the design, we actually get some feedback from the model as to how this culvert is performing. Now, of course, the story doesn't end there. Once we've done the initial design in InfraWorks 360, we can move that information into Civil 3D and do that final detailed design, complete with labels and contours and profiles and cross sections, all of the things that Civil 3D is amazing at doing. In addition, we can also look at maybe creating a more accurate hydrologic analysis in Civil 3D once we get more accurate terrain data. So Again, maybe the scenario is we do that initial culvert design in InfraWorks 360 where we haven't done a survey yet, and then later on we can check that and validate it with accurate terrain data in Civil 3D once we've acquired it. So if we compare the two procedures, one with Civil 3D alone and the other with Civil 3D and InfraWorks 360 together, the story is pretty compelling. With Civil 3D alone, it's a meticulous, detailed process. It's because you're using software that's designed for detailed design. Whereas in InfraWorks 360, it's a 4-step process. It only takes a little over a minute in our example, whereas in Civil 3D it took nearly 8 minutes. With Civil 3D, you need some pretty serious skills to know how to find the flow, determine time of concentration, transfer that data over to HydroFlow. There are a lot of different areas of the product that you need to learn, a lot of experience you need to gain, a lot of training that's going to lead up to someone having the skill set to be able to do what we just did. Whereas in InfraWorks 360, it's a much simpler process, and it only requires a little bit of training. With Civil 3D alone, we needed a second program with manual transfer of data from Civil 3D into that program to do our calculations. But with InfraWorks 360, it's all nicely packaged into this one function. And then finally, with Civil 3D alone, it's a 100% design driven, so there are no assumptions made, and it's an environment where the designer is expected to have full control over the design. Whereas in InfraWorks 360, we're looking for something quicker and rougher, but smart, not just a pretty picture based on some engineering principles, but with some assumptions made so that InfraWorks 360 can create something quickly. The result, with Civil 3D alone, we get a detailed culvert design with the documentation necessary for bidding and construction. So with the two products together, we get all of that, the detailed culvert design and documentation, along with having our 3D model in the context of the surrounding area, and also the 3D graphical analysis of culvert performance that you can actually see in the image above. So InfraWorks 360 is more than just placing the culvert. We can actually do a detailed analysis of it as well, right there in the context of the model. And let's not forget the topic of detailed design. We've been talking a lot about InfraWorks 360 in this presentation, mostly because we know that you already know how big a part of the equation it is. We know that without it you couldn't do survey data processing or many aspects of detailed design. And we know how important it is to you for preparing bidding and construction documents. And without profiles, cross-sections, labeling, and plan production, you couldn't do the work that you need to do. Not to mention the AutoCAD platform that it's built on, allowing you to do all the general drafting tasks like drawing details and adhering to the graphical standards that you're required to adhere to by your clients and customers. So Civil 3D is and will remain a big part of this equation because of the need to use it for detailed design and documentation. We've talked a lot in this presentation about doing certain tasks faster, but we know, as well as you do, that it's about more than that. With InfraWorks 360 added to your toolset, you have additional capabilities on top of what we've already discussed. For example, because of InfraWorks 360's ability to build and analyze multiple designs very quickly, you can give your clients choices very early in the process. And not only that, you can present these designs in a way that's compelling and easy to understand. The old adage applies here, a picture is worth 1,000 words. And imagine being able to readily present your design ideas using the type of imagery you see here versus what you may be doing traditionally. Another capability that InfraWorks 360 can give you and your clients is the power to make decisions quickly and early in the process. What makes this possible? Readily available analytics right in the software. So as you design intersections or bridges or storm systems or any number of objects, you are provided with visual analytics right in the model as you design. And you can see some examples here on the screen. The top image shows a sight distance analysis for an intersection. The middle image is clearance beneath a bridge, and the bottom image is flow performance of a pipe in a storm system. As you can see, the results are very visual, and they serve as companions to the designer always present so that decisions can be made early. And what's also important about this is that the decisions are made based on analytics, not guesses. So the analytics that are shown in InfraWorks 360 are based on hard numbers, calculations that are being performed as the designer designs. And in today's world, our clients want answers faster than ever. In fact, they don't want to wait at all. They want to be involved in the process in real time. They want to be able to check in on the progress of the project at any time they wish. And through the collaboration and sharing tools of InfraWorks 360, this is actually possible today. With the team editing capabilities of InfraWorks 360, we can have an entire group of people collaborating on a project regardless of where they're located on the planet. And for those stakeholders who don't want to have access to the full technology of InfraWorks 360, we can use methods that enable viewing of the model through the web and on mobile devices. But they can do more than just view the model. We've also got the built-in design feed where they can make comments and request changes. And the way this technology is set up, it can easily become a punch list for the design team where they can address the comments and keep track of what's been reviewed and approved. The bottom line here is that team members and stakeholders can stay informed and involved in the design changes throughout the process. So we've been talking a lot about how wonderful InfraWorks 360 is. So you might be wondering, what about Civil 3D? Well, what's been happening is that until now, there's been nothing available for this quick visual preliminary design that you now know InfraWorks 360 is so wonderful at doing. So what have we been doing till now? The industry's been using a tool best for detailed design, Civil 3D, to perform this preliminary design. But now, we've got both tools. Each tool is excellent at doing what it was designed to do. InfraWorks 360 for preliminary design and engineering, Civil 3D for detailed design, engineering, and documentation. So the important thing to remember is that Civil 3D is still a much needed tool, and in fact you simply can't complete your projects without it. So the primary takeaway of this presentation is that with the combination of Civil 3D and InfraWorks 360 together, you have the ability to use the best tool for the job at any given time. When it comes to Civil 3D, you can use it for the completion of detailed design, having full user control with no assumptions made, and the ability to do documentation through tools like profiles and cross-sections, details and labeling, and plan production. And not to mention the ability to adhere to the graphical standards that you're required to adhere to. On the other side, if you need to do preliminary design or early detailed design, and you need to do it fast through the utilization of the cloud and through the application of some assumptions that provide automation in a visual environment that's full-time 3D in the context of up to 200 square kilometers of landscape, cityscape, and whatever features you're able to access through Model Builder, with a product that's easy to learn, then you're looking at InfraWorks 360. Throughout a given day or week or month, you're going to need both of these tools at various times throughout the process of completing a project, and by having both of them at your disposal, you can do what you need to do at the appropriate time. Once again, my name is Eric Chappell, Community Evangelist for InfraWorks 360, and thank you for watching this presentation.